Dear students, let us continue with the topic current electricity. Two important equations that I have explained. One is the equation for the resistance, R is equal to rho L by A, where rho is the resistivity of the material of the wire, L is the length of the wire, and A is the area of cross section, and R is the resistance which is measured in ohm. Equation for current I is equal to E by R plus R, where E is the EMF, R is the external resistance and small r is the internal resistance, and the terminal potential difference, so V is equal to I into R, that is equal to E minus I into small r, and that is equal to E R by R plus R, where we replace I from here into R. I is equal to E by R plus R into R. So, this is the three important equation based on which we are going to solve some more numericals later. Now, the factors on which resistance depends is the length, which is directly proportional to the length and inversely proportional to the area of cross section. And one more factor on which the resistance depends is temperature. So, resistance of a conductor, resistance, this is for conductor, it increases with increase in temperature. Resistance of a conductor increases with increase in temperature. Not only resistance, but even resistivity as well increases with increase in temperature. But when it comes to semiconductor, the variation is exactly opposite. The resistance decreases with increase in temperature, with the temperature increase like this. Similarly, even the resistivity as well. So, resistivity decreases with the increase in temperature. So, that is what the next topic that we are going to learn. Variation of resistivity with temperature is the topic. So, resistance and resistivity increases with increase in temperature in the case of conductor. Resistance and resistivity decreases with increase in temperature in the case of semiconductor. And to understand that, we have a formula. In the case of conductor, resistivity rho suffix T is equal to rho naught into 1 plus alpha into T minus T naught. And if I rearrange, I will get this as alpha is equal to rho suffix T minus rho naught divided by T minus T naught. So, this is okay, into rho naught is there. Okay. So, let us try to understand what exactly these terms are. So, rho suffix naught is the resistivity at T naught, and rho suffix T is the resistivity at another temperature called T. Then their relation, because we know that resistivity changes, right, it increases with increase in temperature in the case of conductor, and that relation is given by alpha is equal to rho T minus rho naught by rho naught into T minus T naught. Now, the unit of resistivity here, which is ohm meter, and the unit of this resistivity ohm meter will get cancelled. That means, we are left with the unit of temperature, which is in Kelvin. Since it is in the denominator, you can write either per Kelvin or per degree centigrade is the unit of this constant called alpha, and that alpha is called temperature coefficient of resistivity. So, what do we call that? Constant temperature, coefficient of resistivity. And lesser the value of temperature coefficient of resistivity means less variation in the resistance. Greater the value of temperature coefficient of resistance means more is the variation of the resistance with the temperature. Now that is in the case of conductor. So what kind of graph do we get? Suppose if I take a material copper, then an alloy called a nichrome, then resistivity here in ohm meter, and this is the temperature in Kelvin. Here also resistivity in ohm meter, and this is the temperature in Kelvin. Then in the case of copper, we get a non-linear graph like this. This is how the variation. That means increase in temperature increases the resistivity. Even in the material nichrome, we get almost a straight line like this. So this is the variation, but in any case there is increase in the resistivity. Okay, as the temperature increases, resistivity also increases. Only difference is here it's a non-linear. It is here it's a linear variation. So this is in the case of conductor, because in conductor variation of the resistivity with the temperature is like this. That is, increase in temperature increases the resistivity. But when it comes to semiconductor, the case of semiconductor, so we know that the resistivity decreases with increase in temperature. So this is the resistivity in ohm meter, this is the temperature in Kelvin. So as the temperature increases, resistivity decreases, and it decreases like this. Okay, it decreases exponentially. So non-linear curve, but with increase in temperature, it decreases. That is in the case of semiconductor. So hope you understood the variation of resistivity with the temperature in conductor as well as in semiconductor. So let's start solving a numerical from one of the exam. So first one here, statement, let's go through the statement. 100 milligram mass, 100 milligram. So mass is given, mass 100 milligram. Conversion is important. 100, which I'll write 10 to the power 2, this 100, milli, again gram, so 10 to the power minus 6 it is. Because of the milli, we get 10 to the power minus 3. Because of gram to kg, another 10 to the power minus 3. That's why 10 to the power minus 6. So when you simplify, you'll get 10 to the power minus 4 kg. Now that is a mass given. Metal is drawn into a wire of area of cross section 0.05 millimeter square. So area of cross section is given 0.05 millimeter square. So first I will write 0.05 as 5 into 10 to the power minus 2. That's rearranging the number. Millimeter is 10 to the power minus 3. But square of it like this. So we'll get 5 into 10 to the power, here minus 6 and minus 2, we'll get minus 8 meters square. So that's the area. Calculate the resistance of this wire. We have to find the value of the resistance R. Resistance of this wire. Given density is given. I'll use the symbol D for density. Is 8.4 in 10 to the power 3 kg per meter cube. Then resistivity rho is given. Rho, resistivity of the material is 1.2 micro ohm meter. So 1.2 micro means 10 to the power minus 6 ohm meter. Okay. So here mass and density is given. So from that we can always write the volume as well, correct? So density is equal to mass by volume, correct? So from this volume is equal to mass by density. Mass by density. How do you find volume of a wire? Area of cross section into the length will give you the volume. Area of cross section into the length. Area of cross section into length will give you volume. M by D. So from this I'll get the length to be equal to mass by area of cross section into density. Okay. So let us use that in the formula resistance. R is equal to rho L by A. R is equal to rho L by A. It's a rho by A, and length formula is here. It's a M by AD. M by A into D. So resistance is equal to, it's a rho M A square into D. What is the resistivity? Resistivity is 1.2 micro 10 to the power minus 6 into what is the mass given? Mass is 10 to the power minus 4 by square of the area, 5 square 25 into 10 to the power minus 8 square minus 16 it becomes, into density which is here, D 8.4 into 10 to the power 3. 8.4 into 10 to the power 3. So let us simplify that first, the entire calculation. So we have 1.2 into 10 to the power minus 6 into 1 to the power minus 4 divided by 25 to the power so 1.2 to the power minus 6 into 1 to the power minus 4 divided by 25 to the power minus 16, then divided by 8.4 to the power 3. So we will get a value 5.714. We are finding the resistance, so that will be in ohm. So hope you have understood. Very easy problem, direct substitution based on the formula resistance, but what is most important is here, length is not given, so this is how you need to relate them. Okay. And lot of conversions are here, so that also you have to remember, like millimeter to meter, then milligram to kg. So only if you do proper conversion, then you will get correct answer. Okay. So let us try the next problem. A wire of length 2 meter. So length is given, length 2 meter, diameter 1 millimeter. I will write the radius. So radius is 0.5 millimeter. That is 0.5 into 10 to the power minus 3 meter. That is the radius. From that I can find the area of cross section. A is equal to pi r square, pi 3.142, and square of this 0.5 square is 0.25 into 10 to the power minus 3 square is 10 to the power minus 6. So that is the area. And resistivity rho is given, rho, which is 1.963 into 10 to the power minus 8 ohm meter, is connected in series with a battery of EMF 3 volts. So EMF is given 3 volt. And internal resistance 1 ohm. So I have used the symbol for it. Normally we for internal resistance we use the symbol small r, but since I have already used for radius, I will write r suffix I is equal to 1 ohm. Calculate the resistance of the wire, we have to find r, and then the current in the circuit. So how to find r? R is equal to rho L by A. Value of rho 1.963 in 10 to the power minus 8. Length L, which is 0.5 in 10 to the power minus 3. No, length is 2 meter here, L, divided by area of cross section is this 3.142 into 0.25 into 10 to the power minus 6. So we will simplify this 1.963 to the power minus 8 into 2 divided by 3.142 divided by 0.25 to the power minus 6. So that is the resistance, which comes out to be 0.05 ohm nearly. Okay. So that is the value of the resistance. Okay. Now how to find the current? I is equal to E by R plus R. So EMF value is a 3 volt. Then external resistance, we have found it here, 0.05 plus inter resistance is 1 ohm. So on dividing, we will get 3 by 1.05. Three divided by 1.05 will give you 2.857. 2.857. It's a current, so that will be in ampere. Right. So again, hope you have understood the problem based on the formula which I have told you. One is the resistance formula, other is the current through simple circuit. Okay. Right. So definitely from the examination, whatever problems that we solve here, most of them are from the previous exam. So just to get an idea is the type of question that normally appear in the examination. So let's go through one more problem that's based on the combination of the cells in series or in parallel. Two identical cells, so number of cells. Let me write that here. So this is a series combination, and here we have parallel. So number of cells is given, n is a 2. Two identical cells either in series or in parallel. So that means they are either connected in series or in parallel combination, give the same current of 0.5 ampere. So current is same in both, 0.5 ampere. Here also it's 0.5 ampere. Through an external resistance of 4 ohm. So capital R is 4 ohm. It's the same thing. Find the EMF and the internal resistance of the cells. We need to find EMF and the internal resistance. So first let's write the expression for current. When n identical cells are in series, the current is given by NE by R plus N into R. So this is the first equation, that's in series. When cells are connected in parallel, n identical cell, the current is given by NE by N into R plus R. Just recall the formula, it's a given. This is the difference, they are not same. Okay, check this here, NE R plus NR, NE NR plus, right. And what is given here in the problem is that the current is same. So we can equate this equation. So equation 1 and 2 are equal, correct? 1 is equal to 2. So therefore, when I equate them, I will get NE by R plus NR, that's equal to NE by NR plus R, and this will get cancelled. So now I can equate this and this, right? So R plus NR is equal to NR plus R. Now let's substitute for external resistance 4. 4 plus 2R is equal to 2 into capital, that becomes 8 plus R. So 2R minus R, here is R, 8 minus 4 is 4. So we have found the value of internal resistance R. Now I can use any one of the equation to find the EMF. So I will use first equation in 1. What is the current? Current is 0.5. So 0.5 is equal to 2 into E, 2, N is 2, okay, 2E by, what is capital R? Capital R is 4, 4 plus and 4 plus, N is 2 again, into small r is 4 here, 4 like this. So 0.5 into, this is a 4 into 2 here, 8, 8 plus 4, 12. That's equal to 2. 12 into 0.5 is a 6, that's a 2E. Therefore, the value V is 6 by 2, which is 3 volt. Okay. So again, one more question from the previous exam, and this time it's based on the combination of cells. Now, any of the numericals you will find it easier provided you know the theory behind those equations. Otherwise, you can't solve any of the numericals. Okay. So, one more numerical. Two cells of EMF 2 volt and 4 volt. So, EMF of the first cell is given 2 volt and that of the second is 4 volt. And inter resistance R1 is 1 ohm and R2 is 2 ohm. Respectively are connected in parallel, so as to send the current in the same direction, which is something like this. This is one of the cell, this is the other cell, connected in parallel. They will send the current like this, I1 and I2, and they add up to give a main current like this. So, this is how they send current in the same direction like this, okay, through an external resistance of 10 ohm. So, external resistance R is given, which is 10 ohm. Find the potential difference across 10 ohm resistors. We need to find what is the potential difference across it. We need to find V. When two cells are connected in parallel, we can find the effective resistance of the parallel combination. Rp is equal to R1, R2 by R1 plus R2. It's also called R equivalent. Okay. We can even find E equivalent, which is even R2 plus E2 R1 by R1 plus R2. So, once we get E equivalent and R equivalent, we can find the main current, which is I is equal to E equivalent by R plus R equivalent. Then we can find the potential difference V using I into R. So, these are the steps involved. So, let us simplify this now. R1 into R2 by R1 plus R2, which is 1 into 2 by 1 plus 2, that is 2 by 3. 2 by 3 invisibly will get 0.6667 ohm. Now, E1 into R2, E1 into R2, that is 2 into 2 plus E2 into R1, 4 into 1, 4 into 1 by R1 plus R2, 1 plus 2 here. So, that is a 4 plus 4 here by 3. That is 8 by 3. That is 3 2s are 6, 20 means 6667. We are finding the EMF, so we get in volt. Now, let us substitute here. What is E equivalent? So, E equivalent is 8 by 3. External resistance is 10. Inter resistance is 2 by 3. So, what we get here is 8 by 3, 10 3s are 30, 32 by 3. This will get cancelled here. 8 by 32 is nothing but 1 by 4, 8 4s are 32, 1 by 4 is 0.25 current, so that will be an ampere. Finally, potential difference. What is the current? Current is 0.25. What is the resistance? External resistance 10 ohm. So, 10 into 0.25 is 2.5 volt. So, again all these equations are given under the theory of combination of the cells. So, that is how I have used in finding the answer, again question from the previous exam. Okay. So, go through all these theory and students start again revising every topic, because in another few classes I will be completing this particular chapter. Then again we will have a test in this particular chapter called current electricity, and complete all the notes one after the other, and do attend the parents teacher meeting, and check your date as when you are supposed to come to the college with your parents. So, again, if you are absent, so you know what kind of action that we are going to take. So, that is why do attend with your parents. You can, in case if you unable to come on that particular day, you can come even on other days as well, but do inform the office people well in advance. Okay. So, I will continue my remaining topic in the next class.